dear students, let's continue our discussion on numerical sessions of the solutions chapter. Okay, and especially we are covering the colligative properties. Okay, so now colligative properties we have studied now in the last session. What are the things? RLVP, and next delta TB, elevation in boiling point, depression in freezing point, delta TF, and the next osmotic pressure. Okay, so you can expect a question from these four colligative properties. Okay, so there are the few topics that you should focus from the solutions. One is what? Raoult's law, Henry's law, and the next ideal, non-ideal solutions. Okay, after that azeotropic mixtures, and then next this colligative properties. These are the things that you should focus. Okay, I hope you will also do along with this that concentration terms, because in all of these we will be using concentration terms like molarity, normality, mole fraction, molality, these things na? Yeah, so these are the things that should be focused from this particular chapter. Now I will be discussing the questions from colligative properties particularly. Okay, so now I told you in the last class itself, I mean in the previous class, what I have told you, see, colligative properties are directly proportional to Van 't Hoff factor I. So how can we find this Van 't Hoff factor I? So using dissociation formula and association now. So for dissociation I equals to 1 plus n minus 1 alpha d. Okay, so based on this I have given you one question also in the previous session. What is that? So I have mentioned alpha d, degree of dissociation is 0.6. I have mentioned for an electrolyte of type this, like this kind of electrolyte. AB2 electrolyte is given, so it is undergoing dissociation like A plus 2 and 2B minus. Okay, these are the ions formed. Okay, and what is the degree of dissociation? It mentioned 0.6. Now find I value. How can you find this? 1 plus how many particles we have after dissociation? See, like 1 plus 2 plus 1, 3, and this is 1. So total 4 minus 1 into alpha d, this is 0.6. Okay, after dissociation how many ions we have? See, 2 plus 1, 3. Okay, so 3 minus 1 into this thing into alpha d. Okay, so how much you will get here? So I value will be, so 1 plus 2 into 0.6. So I will be how much? 1 plus this is how much? 1.2. So how much we got? So this is 2.2 we got. Okay, how much we got? So 2.2. So this will be the I value. So depending upon the degree of dissociation, if I say alpha d, degree of dissociation is 1, so it means what? So it means what? 100% dissociation I can answer. I can say this is 100% dissociation. So in this case how many particles will get? So since 100% dissociation, this is 1, so this one and this one you remove. So total number of ions how many we have? This 2 plus 1. So total ions are 3. So from this we got 3 ions when it undergoes dissociation. Hope it is clear. For association, what is the I factor? Van 't Hoff factor I value. So I given that formula as 1 plus 1 by n minus 1 alpha a. Okay, so these are the two formulas you should remember. Okay, number of ions increases, colligative properties also increases. This is a one relation you should remember, and one more relation, colligative properties inversely proportional to molecular weight of solute. Okay, so now based on this we will solve few questions. Okay, first of all I have a question from osmotic pressure. Okay, hi dear in the chat box. Yes, so look at this, we have a question from osmotic pressure. Read the question once. Osmotic pressure pi versus concentration graph is given. So for a solution gives a straight line with slope this much. Okay, slope this much. The temperature at which osmotic pressure measurement done is. So we need to calculate temperature. What is the formula? We have pi equals to molar concentration multiplied with temperature and universal gas constant R or S I can say. Okay, so now here instead of representing S, sometimes it will be represented R also. Like this you can write. So the graph is pi versus molar concentration Cm. So if I take pi over here and molar concentration here, we will get a straight line they are saying now. So straight line like this with a slope of 25.73. Okay, so that is nothing but see y equals to m, like this is m value, this is slope value, this is x. So x variable here and y variable here, and this is the slope m. So this RT, this is a slope now, m equals to RT, which is equals to 25.73. Okay, so this is the thing we got. So RT equals to 25.73. This data they mentioned slope right now. So from this, by simplifying, R value you can take in bars because they mentioned it as liter bar now. So liter bar per mole they mentioned. So here temperature we need to calculate. So I can take this R value as 0.083 liter bar Kelvin inverse mole inverse. Okay, that will be equals to 25.73. So by simplifying this, you will get temperature equals to T310 Kelvin. How much you will get? Around 310 Kelvin. Okay, so from this what we can write? Look at the options. Do we have that kind of option? See, it is given as 310 degrees Celsius. This is not the one. They are say, we got answer in terms of kelvins. Now convert into Celsius. How much? So 310 Kelvin minus 273 gives how much? 37 degrees Celsius. So we have option number 1 as your answer. Hope this is clear, right? Let me move forward. So just now we also discussed freezing point, depression and freezing point in the previous slide. So what it is saying, the freezing point depression constant Kf of benzene is 5.12. Okay, the freezing point depression for the solution of molality having concentration this much molality mentioned containing a non-electrolyte solute in benzene rounded off to. So what they are asking, the Kf value there, freezing point depression. Okay, so what they are asking, delta, see freezing point depression constant Kf is given as 5.12. Okay, the freezing point depression for the solution delta Tf we need to calculate. Okay, and molality concentration is given as 0.078. Okay, molar solution is given. So we need to find this very easy now. So delta Tf equals to IKFM. So what is the I value? See, for benzene it's a non-electrolyte, I value you can take 1. Okay, into Kf is mentioned as 5.12 into this is how much? I can say 78 into 10 power minus 2 minus 3. So you just multiply this, you will get around, how much you will get? Around 40. So 0.4 and this is 35, 39. So you will get around 0.39 you will get, 0.39 you will get. Okay, so they are asking us to calculate this. See, this is the data they have given now. So you will get this as 0. As per the data we will get 0.40 Kelvin. So where do we have this option? So we have option number 2 as our answer. Hope this is clear. So just use this relation delta Tf equals to Kf m, that's it. You will get the answer. Kf value is mentioned and molality also mentioned. Substitute there, so you will get the answer. Okay, next. Look at this, mass of glucose required to be dissolved for preparation of 1 liter of solution which is isotonic with 15 gram per liter. Again, what is this 15 gram per liter? This is called as strength of solution. Strength of solution. This is also a concentration term. Okay, so this is gram per liter, but in the osmotic pressure we will be using molarity, mole per liter. Na? So CMST we will be using here. Okay, so you can use Van 't Hoff factor I also here. So Van 't Hoff factor 1 into molarity. I can write this molarity, Cm is nothing but molarity now. So that is mole per liter. So how can I convert this gram per liter into mole per liter? So just divide this strength of solution by its molar mass. Molar mass you will get its molarity. So strength of solution is 15 gram per liter. Okay, and its molar mass, how much? Molar mass for urea, it is 60 gram per mole right now. So gram cancel, we have mole per liter, that is 4. So 1 by 4 mole per liter will be your molarity for this solution, for this urea solution. Now isotonic means what? Pi 1 should be equals to pi 2. It means osmotic pressure of glucose and urea should be equal. So for urea, for glucose, how much they mentioned? Mass of urea. It means you can take the formula like this: CmSt of urea or glucose equals to CmSt of urea. So temperature and R value are same, remove that, so you have only this thing, molarity of glucose should be equals to molarity of urea. This is the condition I have to take. So now here I can write number of moles of urea, glucose. Instead of writing weight of glucose, I am writing its molecular weight is 180. Okay, 180 I am taking like this. Okay, volume will be same. Okay, here which is equals to, here how much we got? This is 1 by 4 we got, molar concentration we got 1 by 4. So now how much it is? 4 1s are 4 4s are 16 to 45. So weight of glucose required is how much? 45 grams. Right now, so where do we have option number D is our answer for this question. Right? Yes. Let us move forward. This is again important question. See, a complex of iron and cyanide is 100% ionized. Okay, at 1 molar, if its elevation in boiling point is 2.08 degrees Celsius, then the complex is very easy question. So what we need to do? See, they given delta TB given, elevation in boiling point is given. Okay, and a complex of iron cyanide they are saying 100% ionized. It means there should be some Van Hoff factor contribution. In fact, we need to calculate that only into, and Kb value mentioned. Okay, and 1 molar solution molality we should take. IKBM is a standard formula, right? So I want the value of Van Hoff factor I. So I can write delta TB by KBM. Okay, so here delta TB how much? 2.08 by KB is how much mentioned? 0.52 into, and this is 1. Okay, so how can I write this? 208 by 52 we can write now, removing here point. Okay, so we will be having answer as 4. I value is 4. So I value 4 represents what? So when an electrolyte is given, after dissociation, number of ions formed, that is considered as its I value, Van Hoff factor. Na? So now after dissociation you should get 4 ions from the respective solutions. So look at these, if it undergoes dissociation, how many ions you will get? So 3 potassium ions, 3 K plus ions and 1 complex ion like FeCN 6 times minus 3. So total ions, this is 3 and this is 1. Total number of ions are 4. Right now, this is what you need to take here. Okay, so I equals to N in this case, that is equals to 4. Okay, so we got first option as our perfect answer for this. If you want to verify other options, see, this is already a complex, it won't undergo dissociation. Now if you look at these, how many potassium ions it will release? 4 potassium ions and 1 ferrous cyanide complex. Okay, 4 minus. So total number of ions 4 plus 1, 5 ions are getting, I value will be 5 in this case. Okay, so just find the I value and look at the option which is giving same I value, that will be your answer. So first option is giving same number of ions as I value is same, so first option will be perfect answer, right? Yeah. So let me move forward. Which are the following solution can we expect to be isotonic at same temperature? Just what you need to do, pi 1 equals to pi 2 you should take. So it should be again considered as CmSt, ICM of first solution and second solution, ICM second solution. This is for first, this is for second. See, at the same temperature now, temperature removed, constant value S also removed. So I1 Cm1 equals to I2 Cm2. Just use this, you will get the answer. Okay, so I have tried in the previous explanation also, previous session also same question. Okay, you can try this, if not you can watch it the previous session. Okay, next question. Which are the following, in which are the following 10% aqueous solution will exhibit highest osmotic pressure? Okay, 10%. osmotic pressure they mention na, whenever they mention osmotic pressure with 10%, they haven't mentioned whether it is weight by weight, weight by volume, like that na. So whenever they are writing for osmotic pressure, consider it as weight by volume percentage is mentioned. They mention 10% means what it is? It is given by 10 weight by volume percentage. Okay. So now we know how do we do this? Pi equals to I into molar concentration into S into T. Okay. So here I into molar concentration, I can write weight of solute by molecular weight of solute into volume of solution, and here 1000 if it is in ml. Okay. And from here ST I am writing. So from here you can write I into weight by volume, weight of solute by volume of solution into 100. 1000 I am writing 100 into 10 into ST by MB. Okay. So this is nothing but the percentage they mentioned. So write I into weight by volume, see weight of solute by volume of solution into 100. This is nothing but weight by volume percentage multiplied with 10 into ST by MB. So you have got one final conclusion here. So we need to consider I values as well as its molecular weight. That's it. Okay. So now which is having 10% aqueous solution exhibit highest osmotic pressure. From this you tell me. So all of them are what? All of them are non-electrolytes only now. So its I value is how much now? I value will be 1. So the only factor deciding in this case is molecular weight of solute. That is how it is related. Pi is inversely proportional to molecular weight of solute, right now. So now tell me which is having more molecular weight. Sucrose is highest molecular weight now. So more molecular weight, low like greater the molecular weight, lower the osmotic pressure. So least is for D. Okay. And after that ethanol molecular weight, like glucose molecular weight is more. Okay. So after the pi glucose I can write C, and in ethanol and urea this is 60. Molar mass of urea is 60 for ethanol, C2H5OH. This is around 46 I think so. So this is 24 plus, see 5 plus 1 6, it means 30 plus 16 46 right now. So least molecular weight is for ethanol, so that will contain highest osmotic pressure. Pi B is more than pi A, like this. Okay. Hope the answer is clear, right? Let us move forward again. Here we have one important question. Look at this from JEE Mains 2020. The osmotic pressure of a solution of NaCl is this much, and that of a glucose is 0.2. Okay. The osmotic pressure of solution formed by mixing of 1 liter of NaCl and 2 liters of glucose solution is. So they are asking us pi mix, osmotic pressure of this mixture. So just use this formula, pi mix V mix equals to, what are its components? Sum of its components you take, pi 1 V1 plus pi 2 V2 plus so on, like that you take. Okay. So we require this pi mix now. So given components are only 2. So you take pi 1 V1 pi 2 V2 by V total, V mix I am saying here. Okay. So it means V mix means V1 plus V total volume. So what is the pi 1 value they have given? So it is 0.1 into volume mentioned is 1 liter plus pi 2 is 0.2, volume mentioned is 2 liters, here 2 you take, total volume 1 plus 2, 3. So this will be 0.1 plus 0.4 now, 2 2s are 4, 0.4 here, and this is 3. Okay. So what we are remaining with, pi mix will be 0.5 by 3. I can write this as, see I am removing this point, I am writing 10 power minus 1. Okay. This will be 1 time, we are remaining with 2. Okay. 0.020 means 6. Again like we will get 1.6666 like that now. So I can say 1.67. So we need to express our answer in terms of this like this 10 power minus 3, x into 10 power minus 3. So it means it means we will be getting this as 167 into 10 power minus 3 as our answer. Okay, so what is your answer? 167 is the answer. You should write here as a x value. Hope this is also clear, right? Yeah. So one last question is for you. So just try this question. Just give a try. How can you do that? So do this, and for answer for this I have explained in the last live session, I mean yesterday's live session. You can watch it. Now I am asking you the delta TB, order of delta TB, delta TF, and next RLVP and pi, osmotic pressure. Okay, and these things, along with this I am asking delta TBS, means boiling point of solution, and also delta TFS means freezing point of solution. These are the things I am asking for the solutions. This is the last question, very important question. Look at here. For the solutions of first option 0.1 molar NaCl, second 0.1 molar what I can say, ethanol, C2H5OH, and the next 0.1 molar Na2SO4. Okay, and fourth option is 0.1 molar what will take, next we'll take K3FeCN4. Yes. So how do we do this? I want orders of this, which is more, which is less. You should arrange them. So how do we arrange?
Is this GS gas?
Yes. So how do you arrange this? See, first of all of them have same concentrations now. So keep these concentrations aside. Now look at their the electrolytic dissociation. So NaCl, strong electrolyte, gives I value will be 2, and this is ethanol, non-electrolyte, I value 1. For this it will give 3 ions now, I will be 3. Okay, for this we have 3 potassium ions and 1 ferrous complex ion. Okay, ferric complex ion. Okay, I value will be 3 plus 1, 4, like this. So I told you all the colligative properties directly proportional to what? Proportional to I, right now. So directly proportional to I. So greater the I, greater will be the colligative properties. Up to here, follow the same order. What is that order we'll get? So more the number of ions, more will be its colligative property. 4, 3, 1, 2 will be the order of this many things, because first 4, the red color one up to here, it is what? Colligative properties, number dependent properties. That's why they are increasing with increasing number of ions. And this boiling point of solution will be increases because it will elevate now if number of particles increases. Elevate now, we got this formula delta TB equals to TBS minus TB naught. Okay, which is equals to IKBM. See, I am asking about delta TB. If I increases, delta TB increases. Similar to that, if I increases, this boiling point of solution also increases, no? Yes, that's why I is delta TBS also increasing. What about this delta TF? Delta TF increases, but freezing point of solution decreases, because we have delta TF formula as TF naught minus TFS. Like this we got now in the conclusion of last class discussion. So see here negative sign is there, IKFM. See negative sign, more the I value, here positive sign, more the I value, lesser is the freezing point of solution, right now. So based on this, the order will be reverse. It means 2 greater than, 1 greater than, 2 greater than, 1 greater than, 3 greater than 4. Hope the conclusion is also clear. If any queries or any discussions you wanted to do, you can join our Telegram group. Link is provided in the description box, and also you can write in the chat box. Okay, we will look into it and we'll address it. Thank you for watching. Stay connected with NEET World YouTube channel. Thank you.